Now, basically, a virtual base class is what is the concept when two or more objects are derived from a common base class. We can prevent the multiple copies of the base class being present in an object derived from those objects by declaring the base class, its base class, as a virtual when it is being inherited. Now, such a base class is known as the virtual base class, and this can be achieved by preceding the base class name with the word virtual. So, what you have to write in front of that class? Virtual keyword. Now, see this, the virtual base class is used when a derived class has a multiple copies of the particular base class. Now, for example, in this example, simple example is this one, class B is given, in that the member variable of B is int B. Similarly, next when we are accessing this, inheriting the class B, right, inheriting the class B, so derived class D1 inherits the properties of B. Now what it will inherit? Int B, right? So again, its own member is int D1, suppose. Similarly, the next class, class D2, this is also a derived class, which it will inherit the properties of again the class B, which is a parent class, right? Now this parent class again gives a which property? That is a int B, okay? That is a member function, a member variable of this particular class. So again, its own variable is D2, right? Now one more class, class D3, derived class. Now already these are the parent D1, D2. These are accessing which class? B class. Now suppose these are two parents, right? These are two parents. These are two parents for the derived class D3. Okay. Understand this. This is the D3, which is a derived class, which is a derived class of the D1 and D2, right? So what is that multipath inheritance? In that we have seen that there is a grandparent, and from that grandparent we have the two parents, parent 1, parent 2, and that parent 1, parent 2 is now accessible to this child parent, child 1, grandchild. Okay, so here D3 is having the properties of D1 and D2, right? And D1 and D2 is having the properties of B. This is a parent for D1 and D2, right? So both these parents have the copies of int B. Both these parents have the copies of int B, right? Because it is also inheriting B, it is also inheriting B class. So the int B have the multiple copies, right? Through the D1 class and through the D2 class, which is given to D3. Now D3 is a derived class which has a multiple inheritance. It has a multiple inheritance, right? So it has a multiple inheritance. That means we have here what happened? Multiple copies of the accessing point, that is class B, is going towards this D3. Now again D3 will get confused. D3 will get confused,
Hello.
which has to be used, right, which has to be used for the copies of the its parent is class B. Now for this class B, int B has to be accessed. Now int B, whose int B it will access? Then from coming from the derived class D1 or coming from the derived class D2. These are the derived class for B, but these are the base classes for D3, right? So it is inheriting, right? It is inheriting whatever they are in. What is there in this D1? In D1, if it is accessing D1, what is there in D1? Are you getting my question? What is there in D1?
In D1. and int b.
Yes, int b, which is coming from its base class b, right? And its own is d1. Similarly, for d2, it's coming from the class b, int b, and the same way in d2. Okay, so d2 and d1 doesn't have any problem, but a problem with the copies of this int b, because multiple copies are accessing here through the multiple inheritance. Okay, so d3 going here. Now when we are calling this the object of the derived class d3, and we are making some variable, that is object dot b is equal to 40, the error will occur as multiple copies of variable b are present for the class d3, right? We have a multiple copies of variable b are present in class d3. So where to access through the d1 or through the d2, it doesn't know. So that compiler error comes. Okay, so for sorting out this problem, for sorting out this problem, what it has to do? Now the concept of virtual base class is there. Now make the copies. If more parents are there, okay, if more parents are there, it has to make that parents as a virtual class. Now how? The virtual base class is used when a derived class has the multiple copies of the base class. Here the base class means class B. Here the base class means B. Then the derived class D1, then the derived class D2. You have to make as a virtual. Okay. When you are making this class as virtual, right, then it will go and take actually the base class of this only one copy. When you take this keyword virtual public B, virtual public B in this case, that means it is taking only one copy. Okay, so multiple copies doesn't exist when you take the keyword virtual and you are creating a virtual base class in that example. Now that means multiple parents, though it has a multiple parent for the derived class D3, that is D1 and D2. Now it is accessing the actual only one copy which is coming from the class B, okay, directly. So here when you are writing the main, okay, and you are creating an object dot b is equal to 40. Now this will be accessible by the compiler as it will only having saying that we are making this virtual public B in the D1 as well as into the D2. So that means you have to make the in derived class, okay, you have to make this in derived class that only one copy can exist instead of the multiple copies for that particular class method or the variable exist. Okay, so now this will be accessible for the compiler only because object dot b is equal to 40, it is now stored in the memory. Okay, and the compiler doesn't get confused because we are making the help of the virtual keyword and making the class as virtual base class. Now only one, because you made that class, okay, d1 and d2 as a virtual, so d3 will get a copy, only copy, one copy which exists here only. Okay, it exists only here only, so it will access that and it will assign that value into the memory location. Okay, that's what we are sorting this problem, and we call it as a virtual base class. We call it a virtual base class, so it is existing virtually, so it is existing virtually. Okay, so this is what the virtual base class concept. Similarly, we have the virtual functions. Similarly, we have the virtual functions. Now, when this virtual function comes across, there is a concept of polymorphism. Under that concept of polymorphism, there are two types of polymorphism, actually compile time polymorphism and the runtime polymorphism. One is the compile time polymorphism and another is the runtime polymorphism. As the name suggests, compile time polymorphism is exist only at the compilation time, and runtime polymorphism comes at the execution time. Okay, so there are again the two types of compile time polymorphism: operator overloading and function overloading in compile time polymorphism. And in runtime polymorphism, there is a one type which is called as virtual function. So runtime polymorphism can be accessible with the help of virtual function. Runtime polymorphism can be accessible with the help of virtual function. Now what is meant by polymorphism? Actually, this polymorphism concept we are going to learn again ahead in the next unit. But right now for this particular concept, what is polymorphism? As name is there, poly means many, morphism means forms. So a function exists in many forms. Function exists in a many forms. Okay. For examples, we have already seen that polymorphism concept in the first unit, right? So one function can act as in many forms, accessing suppose first time for integer values, then for the float values, then for the double values, then for the string values. So only one function can exist in multiple forms. Okay, so that type of morphism can be done for the compilation period or for the runtime period. So when we want this to be done with the help of runtime time, then we have to use the virtual function. So until and unless when execution takes place, the actual which function has to be taken is not known until that period. Okay. So the before going for the virtual function, there is a concept of the abstract class. See, what is now abstract class? Sometimes we don't know the implementation of the function. Okay, so that implementation cannot be provided in that particular base class, because at that moment we don't know the implementation. So such class is called as an abstract class, because we have not written the implementation part of that particular function in that base class. Such a class is called as abstract class. For example, let us have a shape class. Now this shape class is a base class. Okay, shape class is a base class. Suppose we are writing a class and we don't know what is exactly in shape. Okay, so just right now we are just started with the base class shape. Okay, and started with some method, and further implementation of that method has to be depend upon that derived classes. Okay, so we are not writing the definition, we are just created a draw function in shape. This is a base class, and every derived class must have its implementation of the draw method. So suppose we are deriving a class which is a rectangle class, okay, or square class or triangle class. So these are the derived classes which is coming from the base class shape, and we are writing the definition of the draw function in the rectangle class, in the square class, in the triangle class. Okay, likewise. So at that moment when derived class will access this draw method, it has its own implementation of the draw method. Okay. So likewise we can create object. Okay, we cannot create the object of abstract class, so we have to create the object of the derived class. So for example, we are going to look in detail the example also. Abstract function doesn't have any body. That is the point. Abstract function doesn't have any body. It is a null function. Then we must implement all abstract functions only in the derived classes. Okay, only in the derived class. So a pure virtual function or the abstract function exists in abstract class. As I have told you, shape class is a abstract class, and you are writing a abstract function or a pure virtual function. It is also called as a pure virtual function, and this function which we don't have implementation part, we only declare it. For example, draw function, we are only declaring it. Okay, so a pure virtual function is declared by assigning 0 in the declaration part. Okay, so we are assigning a 0 to that particular function. So pure virtual function is declared in the base class, and that has no definition. Now no definition means you have to write the virtual keyword, the return type, and the function name is equal to 0. This becomes your pure virtual function or abstract function, and which you are going to write in the abstract class, which you are going to write into the abstract class. Now already told you, abstract class is a class where you are not writing the details of the implementation. This is just a base class having certain method, and you are implementing that certain method into its derived classes, So a pure virtual function or a abstract function is having a definition as such, like for example, virtual void show function is equal to 0 and semicolon. You are not going to the implementation details. You are not writing the function body. Okay, is it clear to you?
Yes, ma'am.
Yes, ma'am.
Yes, we are going to see the example also. So rules for virtual function must be the member of some class. Okay, then cannot be a static member. It should not be a static member, because static member is accessible for everybody. So it cannot be static member. It access to object pointers also. Okay, let us having all examples. Can be a friend of another class and must be defined in the base class only, even though it is not to be used, but it has to be defined only in base class, not in a derived class. The prototypes of a virtual function of the base class and all the derived classes must be identical. If suppose you are writing in the base class that void function, then also in derived class you have to write void only. If you are writing int, then you have to write int in the derived class as well. So this prototype matching should be there in base as well as in the particular derived class. Now simple example, we are going to the simple example here. Now what is this? Class base. Alright, class base. This is your member variable integer x, and you are writing this base class as virtual void function is equal to 0. Now what is this virtual void function 0? As it is written as 0. क्या हुआ अब ये? This one is virtual void function is equal to 0. If you are writing, what we call it as
Virtual function.
virtual function, but a pure virtual function. What we call it as a pure virtual function.
Pure virtual function.
Pure virtual function. Okay, and this class base is called as class. Yes. This class base is a abstract class. Very good. So this class base is an abstract class because we have written a pure virtual function inside it. So this class base is an abstract class, and Now the next method is int get x and you are return x. Okay, means another method you are doing something in that method. This is a method having certain body, but earlier one virtual void function is equal to 0. That means this is the pure virtual function. So a class having a one pure virtual function is called as the abstract class. Now this is your abstract class, and now next you are writing a derived class in which you are going to have the definition for this function. Okay, fun function, you are going to derive this inside the derived class. Now class derived, and it is having the public base. Class derived is having its own variable int y. Then in public you are writing the void function. Now this void func, this is a function which you are going to write in the derived class. Cout function call. What does this mean, cout function call? You are writing something in the function body. That means in derived class you are writing the function body of this function. Now see that prototype is same. Here also you have written void. Here also you are writing void. The prototype match is there, right? Then you are writing a, a main function for the execution. Now you are writing or declaring the object of the derived class object D. Now you are calling the D dot function and return 0. Now tell me what is the output. Hello, are you listening? What will be the output?
Function called.
Function called. Very good, very good.
Called.
Function called is the output of this particular example. Very good. So you will got this idea. So base class, in this base class we are not defining anything for the function, but in the derived class we are writing something for this function call. Okay, so this function is called as the pure virtual function because we have not defined, we are not written a body for this function, but we are writing this body inside the derived class. That's why this is called as the pure virtual function. Inside this pure virtual return, whenever you write a pure virtual function in any class, that class becomes the abstract class. Okay, now this is a simple example. Similarly, in you have to write a more specific example. Now as already told you, shape example we are discussing later. So this is the shape example where class shape is having a one method, which method is int area. This we are calling as int area. Int is a prototype, integer, area is the name of the method, is equal to 0. This is called as pure virtual function, as virtual keyword is there, right? As virtual keyword is there. So you are declaring like this, and then you are writing some method of this function. This is an abstract base class, as shape is a having only declaration part, and you are writing this one method as a pure virtual method or pure virtual function. And another method, in that you are taking a parameter int w and assigning width is equal to w. This is another variable for this class. Okay, so then you are having the next way, you are having the function to set the height. Okay, so in protected, actually you are written the int width and int height in protected part. Are you getting? In public part you are written methods. In protected you are written a member variable width and height. All right, understood? So this, like, you are written the shape class. This shape class is a abstract class. Now you are deriving classes. Rectangle, you are writing class rectangle, which is having the base class shape. Similarly, you are going to write the definition of this int area into this particular rectangle class. and you are writing int area, return width multiplied by height. Similarly, for the triangle you are writing, again accessing public shape, and you are writing int area, return width multiplied by height divided by 2. Okay, likewise you are accessing this rectangle class, which is inherited by the shape class. Similarly, triangle, which is inheriting the shape class, and then you are going to access it execution through the main function, and you are having the object of the derived class, not the base class. So you have that rectangle R and triangle T, these are the object of this derived classes. Then you are setting this R dot set with and passing 5, so it is going to access its, because the derived class have no definition for this set width, it is going to have call the body over here, and it will take out the width is equal to W. W means 5. So width getting 5 and height getting 10. So 5 and 10. When you are T is the object triangle, set width 20 and set height as 8. So it is accessing again this methods of the shape class. And when you are writing R dot area, that means it is having this method int area, which you have written as int area in shape class as a pure virtual function, but you are writing the implementation part in the derived class. So int area in the rectangle, width multiplied by height, that area call will be there, and you are having the answer over here, cout statement. And again the area of the triangle is, again you are calling T dot area, so the answer is going here. So cout statement will come here. Okay, so when you run this program, you will get the area of the rectangle is, multiplication karo R dot area, what is the area, width into height, you will get here. Yes, whatever answer you will get here. Similarly, the area of the triangle is T dot area, so it go here and calculate that and write here. All right, understood? Shape example.
Yes, ma'am.
Yes, ma'am.
Everybody understood? So can you write the one more part here, like this shape, as already rectangle you have written, then triangle is written, then you can again add square and circle also from your side and write down. Okay. Yes.
Okay.
Yes, ma'am.
Now the features of abstract class. Features of abstract classes. First feature is class is abstract if it has at least one pure virtual function, as we have seen this already in detail. Okay, in again in the following example, for the this particular test, class is an abstract class because it has a pure virtual function show. Okay, so I have one by one I have shown this as per the example. So class test int x virtual show void show is equal to 0, in get x return x. So when you are declaring this, test t return 0 output. Why this is a error, compiler error, cannot declare variable t to be of abstract type, because abstract type क्या नहीं करता, it doesn't have the object, only derived class has the object, right? So it has getting the compiler error, cannot declare variable t to be of abstract type because this is the abstract class, right? So you have to write instead virtual void test scope resolution show. All right, virtual void test scope resolution show instead. So this is our first feature, that is class is abstract if it is has at least one pure virtual function. So in this example of test we have shown that it has a pure virtual function show. So we cannot call or declare the object of that particular class because that class is an abstract class. And when it becomes abstract class, when it has at least one virtual function. So we cannot write the object of that. All right, we cannot write the object of that particular class. Remember these things, okay? So right now we'll have time limit. So in the next lecture we'll see the one by one features of the virtual class as well as the virtual function, and we'll stop over here. Okay.